Hey, before we start, let's first take a minute and talk about cake, because that is always very important. Let me take you to the 1940s, where the very first powder-made, ready-made cake came onto shelves. So you just had a bit of powder. All you needed to do is add some water, and voila, you had a cake. Now, the manufacturer thought, that's quite revolutionary. That's really, really good. But customers didn't like it. So the manufacturer went back, did lots of interviews, tested different product combinations. And what they figured out is if we tell people to actually add milk and egg themselves, and we take out the dried milk and dried egg from our powder, take that away, suddenly people liked it. It tasted exactly the same. There's no difference, but people enjoyed it. Which, by the way, is the reason why to this day you have to add milk and butter and egg yourself. Now, what's going on here? It's something weird, right? People seem to enjoy having a little bit of manual effort. Similar thing happens when you think about airport design. That's my daughter baking a cake there. In airport design, in the old days, people left the plane, went 30 seconds, and that's where they had to collect their luggage, but they had to wait for the luggage to actually arrive. So they waited 5, 10, 15 minutes, which in surveys, they really didn't appreciate. So some architects decided, why don't we put in a little trick and see how that goes? So they made the people leave the plane and walk around following little signs. Go left here, go right there, walk through those tunnels for 5, 10, 15 minutes until they arrived exactly where they arrived before, just next to the plane essentially. But now when they arrived, the luggage was already there or was just popping out. Did another survey, people liked that a lot better. Seems having a little bit of manual effort is a good thing. Or if you think about IKEA, people really like their IKEA furniture. Typically, it's not expensive, so that's good. It's also typically fairly good design, great. But what also has an impact is that you have to build it yourself. So you get a sense of ownership. Or, this event is organized by an employee of Lego. If you talk about Lego, the whole business model is go build, go own, go be involved. But there is something deeper here that relates to modern generative AI. How would you feel if I tell you all those stories that I told you, all the pictures, this entire presentation was done by AI? All up by Gemini, because I asked it to come up with some hook stories. Would you feel deflated, disappointed, or maybe cynical? Yeah, I knew that, of course. How, on the other hand, would you feel if I tell you, no, the pictures are real, this is actually my daughter, the stories are real, this entire presentation is done by me without the help of AI? Feel better? Do you appreciate that? Or do you think I'm a boomer who just still doesn't understand the power of AI? Well, the stories are true, the pictures are true, and the entire talk is done by myself, as is this presentation. But not because AI couldn't do it. It's because I like the creative process, I like the manual effort, the thinking, and also I don't want to lose the skill of crafting stories and making these presentations. Which brings us to the core thesis that I have today, which is that LLMs, generative AI, does not know how to build simulation models well. And we'll come to that, what I mean by that, and we'll specify it. But before we dig in, let me briefly introduce myself. So my name is Ben. I've been building simulation models for over 15 years now for industrial clients. I started out with a PhD in complex system simulation. Then I joined a UK consultancy building simulation models for industrial clients to make decisions. Then I joined McKinsey, building simulation models for industrial clients making decisions. And for the past 7 years, I have my own company building simulation models for industrial clients making decisions. Now, at the core, what I'm doing is basically this. So I build little toy worlds of decision support models for factories, warehouses, supply chains, any continent, any industry, any scale really. What is similar to all of them is that they help make decisions. All right, so before we dig in deeper, disclaimer, LLMs are great. Gen AI is an amazing technology. Go use it. Go study them. Go apply them. They're fantastic. What we do in this talk is focus on one pitfall, that LLMs fail at helping you build serious simulation models. And with serious, I mean decision support tools for real clients where real money is on the line, that need to be well crafted, well architectured, scalable, reproducible, reusable, all those kind of things. That doesn't mean that non-serious models are bad. Toy models built with AI are fantastic. Educational models are fantastic. There's no judgment. It's just that these serious models, you cannot rely on LLMs. And I will tell you why that is. So let's zoom out a little bit and actually put ourselves into the shoes maybe of an engineer of a car factory. And your manager is basically telling you, we have a big decision. I've heard about the simulation stuff. I want a simulation model. We simulate that. So as a simulation modeler, or as an engineer who has no idea about simulation modeling, you turn to AI. In this case, I'm using Gemini, but it doesn't matter. And you're trying to figure out, well, how can I simulate a car factory, let's say. So let's pretend we don't know a lot about the model, but we work at that company. Now let's come up with a reasonable prompt, right? How would I design such a model for car factories? What structure do I need? What kind of questions would I need to ask to my stakeholders? It's a fair prompt. What's important here is not the prompt. It's not about prompt engineering, getting better at prompting. Actually, it's entirely irrelevant even which LLM you use, which prompting technique you use, if you use prompt all, or if you use agentic AI, it doesn't matter. My point is a different one, as you'll see. So let's stick with this for now and see what we get out of our LLM. It's not all bad, right? So it does actually tell us that there is a core structure to building such models. It maps entities to certain things in our factory. It maps other things to certain things in our factory, which is not entirely wrong, let's say. Let's be charitable. It's also not completely right. It really depends on the context. But okay, let's be charitable. It's not a bad stuff, but it does get bad. So then starts to give you the questions that you should be asking to stakeholders. And it comes up with stuff about takt time, shift patterns, changeover time, MTBF, rework. All these are very bad questions to ask at this stage. Completely irrelevant questions, really. You would ask those a lot later, not at this stage. Far too detailed. So, not really good. But as a modeler, as a new modeler who has no idea, you wouldn't be able to judge that, would you? It gets worse. It actually then comes up with the technical design steps. First, you build the logic, then you add stochastic elements, and then you do performance metrics. And everything about this is just wrong. You don't first build the model, then add randomness, and then do some performance metrics. That's not how you build models at all. I don't know how you can even go beyond wrong. This is wrong, wrongest. So maybe as the engineer, you have a hunch, I don't really trust LLMs. Maybe I should ask in a more generic way, So he does that and tries to figure out, how should I actually go about building such a model in general? How do I build such models? Well, explicitly asking, how do I do this well? And again, not all bad here. It actually does say, we need to balance accuracy with simplicity. That's fair, but it also does say that you can break things without costing a cent, which is patently false and ridiculous, really. So let's be charitable still. It's okay. You need to balance detail with speed, but it gets worse as usual. And now comes up with a 5-step simulation workflow. And the first step, is okay. You do start with objectives and scope definition mostly, but again, not always. It really depends. But then it gets much worse. You don't, as a second step, do the data collection. You don't, as a third step, map out the logic on paper or whiteboard. You don't then, and this is the worst advice, step number 4, translate that logic into a simulation tool. and you don't, as a last step, do V&V. Everything here is completely wrong. So, man, again, wrong, wronger, wrongest. What can I say? Everything here is wrong. Again, as a beginner, you'd have no idea about this. And then it gets worse. If you build these kind of process simulation models, you might have heard about paradigms like discrete event, agent-based system dynamics. Our LLM has heard about those as well. And it just says, well, you can map those quite nicely on your simulation focus, which again is just wrong. What else can I say? You can't just map those. It doesn't even mention that you can mix and match those. There is just everything wrong here. So, okay, a lot of stuff going wrong, but I don't want to, again, diss LLMs here. We need to learn how to use those tools and how to build models well, because clearly LLMs have no idea how to do that. But before we go there, let's first figure out what's going on here. Why are they so bad at this kind of stuff? Now, what we're observing is just LLMs writing answers. This is what they're good at. This is what they've been programmed for. They answer no matter what. The problem is that the questions that we ask, no real answer. They're kind of open-ended, and the real answer is it depends. And then you iterate and ask questions about the system and try to figure out what the real model purpose is. Now, with the latest AI tools and skills and Claude Code, you can actually trigger the AI to keep asking you questions. But this doesn't matter. They still don't fundamentally know how to build simulation models. So even if you force them to do that, they will still not be able to help you well. Why not? Let's have a look at my very modest bookshelf of simulation books. For 15 years, you would say that's not a lot of books, Ben, and it's not. Most of my knowledge is online, is on my hard drive and in my head, to be honest. Books are really not very good guidance when it comes to building simulation models well. These books have been written to help you build toy models well, or help you build academic models well, or help you solve one specific issue. This is what LLMs find when they go out and train. The free books that are out there. They also find forum entries, they find academic papers, they find conference proceedings, and they find the online help of simulation tools, freeware and commercial tools. Now, what they learn from those is not what we are after. What they learn from the books is how to build toy models and how to teach students how to build simulation models. But not well, not for the purpose that we are talking about, serious models. What they learn from academic papers is how to build academic models. What they learn from conference proceedings is how simulation students build academic models. And what they learn from the online help of tool vendors is how to build models with that tool, which all doesn't help us. More important, everything that they find taken together is almost nothing for an LLM compared to what they find about Java, programming, I don't know, psychology, all the kind of stuff that you find millions and millions of documents online. For simulation modeling, you find very little compared to other things. So our LLMs will just fill in the gap from similar topics, but they fill in quite confidently, which is what we've seen. So it's a massive lack of training material. Also, the usual stuff, the usual limitation of LLMs, their architecture is limited. They're inherently stochastic, and even if they get better, which they still do, they just reformulate what they see in their training material. There is no magic. There is no reasoning. All these are just misnomers. So they cannot fundamentally get massively better, but they get better at filling stuff in. It's like the fundamental flaw is that you ask an LLM, how do I paint a Mona Lisa? The LLM goes out into its training material, finds books about how do you paint the Mona Lisa, but the books haven't been written by Leonardo da Vinci. And even if it tells you then how the books tell you to paint a good Mona Lisa, you still cannot paint a Mona Lisa. And if you tell the LLM, paint a Mona Lisa, it can give you a digital copy, but it cannot paint a Mona Lisa. So you still won't paint a masterpiece. So Well, how do you then draw a masterpiece? How do you model simulation models well? Now, I keep on talking about art, and there is no coincidence there. Check out this painting from an artist. Real artist, that's not me. This artist, when he painted the picture, had a vision first. What do I want to paint? Windowy landscape, a little bit of sunshine, should feel cold and kind of nice. So the artist comes up with an overall goal or purpose in his or her head up front. Similar for simulation models. Before you start building, before you start scoping, before anything, the very first thing is you need to find out the purpose of that simulation model. What do you want to solve? And it should not be, I want a digital twin of my entire factory, because that's not a purpose. That's a recipe for disaster. You need to have a fairly tight focus. You can't, as an artist, just say, I want the most realistic picture of everything. You know, that's not art. So what does an artist do next once they have their vision in their head? The very first thing is they start with a very rough sketch. But in this sketch, they already implicitly defined a rough scope, still wiggle room, they can still move it around a little bit. And everything in that scope is already loosely defined, but it's all there. The trees are there, the mountains are there, it's all roughly there. This is exactly how we build simulation models well. If Jeff Bezos calls me today and says, Ben, I need an entirely really good model of the global Amazon supply chain, when can you have the first draft? The honest answer would be today. I can have a super simple model of the entire scope of this problem, global Amazon supply chain, with everything in there, but everything ridiculously simplified. Like this picture. If you tell somebody, well, this is art, they say, come on, my daughter could paint this, I could paint this. This is not art. If you look at a simulation model at that stage, it's the same thing. It's ridiculously trivial, but that's the entire point. What does the artist do next? They don't just go about and now put in details everywhere. Instead, they just put rough colors everywhere. Basically, refine every part of the model a tiny little bit so it just nudges itself towards becoming a picture. Not art yet, but a picture. With the simulation model, after day one, I would do the same. For maybe the first week, I would just refine each part a little bit. So we have actual warehouses and real locations. I can see trucks moving about, whatever. But when the client looks at it, like this picture, they already see, this will shape to be the system that we're talking about. Cool, I recognize this. This is the landscape. Fine. It's not art yet. I'm not going to buy this and put it into my flat, but you are getting that. That's exactly how you build a week one model of a serious simulation model. Now, what does the artist do next? He steps back and does not think, let me add details everywhere. This is going to be a digital twin of my landscape. Instead, he or she thinks, what was the purpose again? What did I want to convey? And then they just grab a section of that and refine that section a little bit. So add a little bit of detail to a subsection where they think they have the biggest impact on the overall picture, which again is exactly how you should work as a simulation modeler. You take your rough model, you remember what did we want to solve again, and then you decide, well, which part of the model should I refine a little bit? Not make it realistic, not translate the real logic into the simulation model like our LLM suggested. No. You add tiny little details, you test everything again, and you see, did I get a little bit closer to where I want to be? You compare KPIs or whatever. From then on, just like the artist, you keep on doing that. Step back, decide on an area, add a little bit of detail, test. Did we get closer? Until, like the artist, at some point will say, this is good enough. I can't be bothered anymore, or I've achieved my purpose. An artist will not continuously add details again and again and again until it's perfect. No artist ever has a perfect picture. Same with the simulation model. At some point, you pull the plug and you say, we are good enough now. We have achieved our purpose. We can answer the questions that we had. We don't have a digital twin that can do anything. We don't want that. Because if you keep adding details, Now you're falling back into the original trap and you'll end up with something like that. A painting by number picture. It's not really art. It has details everywhere. It's completely prescribed. It's ultra realistic, but you can't really do anything with it. Let's say we follow the current trend in industry. Omniverse, NVIDIA, digital twin. Yeah, we've got these highly realistic renderings. And managers think, oh, if only I had that of my factory, I could do everything with it. You can't. First of all, let's assume you could build a hyper-realistic model, 99% accurate, or even more. You can't, but let's assume you could, maybe of the Amazon global supply chain. So Jeff Bezos looks at the results, and it predicts there's going to be a 3% revenue drop in Ireland next month. So Jeff wants to know, well, why? Let's pretend again we have the cleverest AI and the cleverest team of data scientists, and they dig into the simulation model to try to figure out, where did this come from? Why is this happening? Which again isn't possible, but let's pretend we could. The honest answer of that would be, there are 7,312 reasons for the drop, Jeff. And they span from the last 30 years to the last 5 minutes. But, Jeff isn't intimidated, so he thinks, well, sort those reasons for me by impact on the revenue and show me the top 100. What you'll now have is 100 reasons that each have a tiny impact on that revenue drop, and only the sum of them creates the 3%. So you can't really act on that. You have analysis paralysis. So even if you could have such a model, hyper detailed, you can't do anything with it. And you can't have such a model. So you should not paint by numbers. You should not aim for a hyper realistic digital twin. You need to stop at some point when you've achieved your original purpose, which can change as well. Doesn't matter. So the problem with digital twins and paint by numbers is that it looks good, it looks promising, but nobody can actually tell you where to fill in what. There are no lines like in paint by numbers that you just fill out when you map reality to a simulation tool, or what colors to put there. So you have to use this iterative artist approach to nudge yourself closer, and you have to do a cutoff point where you solve the original purpose. Otherwise, analysis paralysis. Now, the problem is now, how do we marry this with LLMs? They don't know about this. They can't help you there. They can't tell you where colors go. They can't tell you how to abstract reality, because it always depends. And even if they could know that, they wouldn't even know how to translate that to simulation tools. Even with skills, MD files, with MCP servers, all that kind of stuff, they fundamentally lack good training. So this situation will not improve anytime soon, because the training material is not growing. Nothing out there is exponentially growing and teaching LLMs how to build simulation models well. So unless something fundamentally new comes along, which Jan LeCun is actually working on with world models, we'll see, that's very promising. But unless that happens, unfortunately, you still need experts or learn yourself how to build simulation models well. And that's especially true in basically any niche area. These LLMs hit blind spots, unknown unknowns, and they just fill in the blanks. But you will never know that they filled in the blanks. Experts will know, so you should become an expert. Now, what happens next? What do I think happens next? Maybe in the next 5 to 15 years. Nobody really knows, no question about it. I think what will happen is the usual hype cycle. We're now on the upwards trajectory there. People are building simulation models with LLMs in their browsers, little toy models, little educational models, which is fantastic. These will never be able to scale to real industrial problems, which is just in the nature of things. That's what I was talking about. There's no problem with that, but we will hit that trough of disillusionment where people thought they could do that and now realize that's just not possible. So you still need to learn how to build simulation models well, which is manual and slow. LLMs cannot really help you there. They can help you build the model, but you have to design and decide how to build the model, what model to build, what purpose, when to cut off. No LLM can help at all. Long term, we'll see the slope of enlightenment, where I think spec-driven development and test-driven development will be very, very important for simulation modelers. Good architecture. So basically all the things that advanced experts have been preaching for the last 20, 30 years basically make a comeback now and become as important as they ever have been, really. Now, final bit of advice. Of course, use LLMs. Don't shy away from it. It's amazing technology. Learn how to use it. Learn how to wield it. Be aware of unknown unknowns, especially in niche areas like building simulation models well. But do not use them for actual painting. You have to paint. Keep the skill of building models well alive for now, and we'll see where that takes us. It may become irrelevant. I don't think it ever will. Thanks a lot.